Good day, everybody. How are you all? Hope you are doing great today. So here I go. The following data set has to be analyzed, and they have given us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 22 data points. Part A, is there any outlier in the data set? Part B, find the 31st percentile in this data set. And part C, what is the percentile position for 38 in this data set? So, solution. Solution. Enter the data in list 1, which is short form is L1 in the NTI-84 calculator. So to do that, we'll first clear the memories of the calculator. How we press, first we press the second button on the top left of the calculator. Then we press the plus button on top of the enter button on the bottom right. Then select number 4. We will get clear all list on the calculator screen. Hit enter. Next is to press the enter button. And when we do that, okay, we will get done. So let's do it. Second button, then the plus button on the bottom right corner on top of the enter, then number 4. Okay, so second button, then plus button, then number 4, clear all list on the calculator screen, then hit enter, done. Okay, number 2, press the stat button, which is in the second row. Press the stat button, then number 1, which is edit. Enter data in L1. So stat button, number 1, edit, enter data in L1. So 14, then 43, then 38, then 49, then 31, then 27, then 39, 59, 9, 10, 54. That's the first row of data. Then 14, 25, 26, 9, 46, 30, 24, 41, 26, 27, and then 14. Okay, so we have entered 22 data points in L1. After 14, the last point, we hit enter, and now our cursor sits on the 23rd line in L1. Okay, that's why at the bottom left corner you see L123 as if it's waiting for us to enter the 23rd data point, which there is nothing. So we won't worry about it. So how do I do the remaining calculations? So after entering the data, then number 3 is after entering data in L1. Okay, then press the stat button again. Then highlight calc. Highlight calc means move the cursor by the right cursor key. That is, press the right cursor key to move the cursor on top of calc and then select number 1. So stat button, highlight calc on the top row, then select number 1, which is 1 var stats. This will only appear once you have highlighted calc on the top row. Next screen, you will see these 3 lines. The list is always set at L1 where we have entered the data. The next line is called FREQ, short form of frequency list. Okay, frequency list. This should be empty. Nothing should be there. So leave it empty. Okay, if it is not empty, make it empty by pressing the clear button, which is in the extreme uh, third row, of calculator trees. If you have something after the frequency list, then only you hit the clear button. Otherwise, don't worry. Bring the cursor on calculate and hit enter. Okay, calculate and then enter. Cursor on calculate and then enter. Now we are basically looking for the 5-number summary. So if I may move this a little bit up, the numbers we are interested. The first number is Q1, which is way down. Rather, the first number is not Q1. First number is minimum, min-x, that is the minimum, that is equal to 9. Then we are interested in number 2 is Q1, which is 14. And notice after Q1, you have a down arrow key like this. So press the down cursor key. This indicates that we have to press the down cursor key to get the other numbers. Number 3 will be mid or median or Q2. And that is equal to 27. Then number 4 will be Q3, which is 41. That is the third quartile. And the last, you scroll down to get the max. Max X is the maximum number in the data set is 59. So the first thing we are going to calculate is IQR, is the interquartile range. Why? Because this gives the range of the middle 50% of the data, interquartile range. That is equal to range, that is maximum minus minimum, range for the middle 50% of the number. So IQR is actually Q3, interquartile range is Q3 minus Q1. In our case, it is 41 for third quartile minus 14, okay, is 27. So this is your interquartile range. Now, in order to find the outliers, we have to take multiply 1.5 times IQR. This is multiplication in parentheses. That means 1.5 times 27. Okay. And that will take you to 40.5. What is this number? This is 1.5 times IQR. Now to find the lower outlier boundary, from Q1, we subtract 1.5 times IQR. Now what is our Q1? Our Q1 is 14 minus 40.5, which is minus 26.5. Okay, now if I pull, create some more space. So we look for numbers, look for any number less than, this is important, less than lower outlier boundary. Outlier boundary of minus 26.5. No such number in the data set. In the data set. Hence, there is no outlier on the left. No outlier on the left. On the left. No outlier. Okay. So this we did by lower outlier boundary. Okay. Now we will calculate the upper outlier boundary. Okay. So upper outlier boundary. To find the upper outlier boundary. Upper outlier boundary. Upper outlier boundary is Q3 plus 1.5 times IQR. What is my Q3? It is 41 plus 40.5. 1.5 times IQR. So this is 81.5. So now we are going to look for any number greater than 81.5. How do I do that? There's an easy way to do that. Let me show you. So in your calculator, okay, put it on, then press the stat button. So press the stat button in your calculator. Then select number 2, which is, then select number 2 or bring the cursor on number 2 and hit enter. So now on your calculator screen, you will see sort A. A stands for ascending. Ascending means lowest to highest. Lowest to highest. Okay, sort A, and there is a parenthesis. Now I have entered data in L1, so I need to get an L1 over here. For that, I will press the second button and then number 1. Okay, second button and 1 gives me L1. That will lead to L1 and close the parenthesis, right parenthesis, and hit enter. Says done. Why did I do this way? Then the numbers are arranged in L1 from lowest to the highest. So how do I find that out? Again, press the stat button. Then number one. And indeed, the numbers are arranged from lowest to highest. Numbers arranged in ascending order. Ascending order. Ascending order. Lowest to highest. So scroll down. Scroll down in L1 with down cursor key. With down cursor key. Okay, looking for numbers greater, look for numbers greater than 81.5. How many numbers, if there is any greater than 81.5? Keep scrolling down till you see any number greater than, there is none because the highest is 59. No number is in this list in L1 is greater than 81.5. Thus, there is no outlier on the right. No outlier on the right. So what is the bottom line? No outlier on this data. No outlier on the left, no outlier in the right. Okay. On the right also. Okay. So that answers, let's take a look. So first we are supposed to find out any outlier. There is no outlier in this data set. Then we are supposed to find, please do not quit right away because I'll give you some important tip at the end of this program. So please stick around and please subscribe to my channel, Math Science Topia, where I've solved all kinds of algebra problems just for you. 31st percentile. So now we have to find the 31st percentile. So part B. 31st percentile. So how do you do that? The formula for that is P over 100 times N, where P is percentile, N is sample size. In our case, P is 31 and N is 22. So if I plug in this position formula, 31st percentile, 31st percentile is the number is the number in the position 31 by 100 multiplied by 22. So it's like 31 times 22 divided by 100 in your calculator. So let's do that. 31 times 22 divided by 100 is 6.82. So since this is greater than 6.5, round it to the 7th. So number in the 7th position is the 31st percentile when the numbers are arranged from lowest to the highest. When the numbers are arranged in ascending order. Arranged in ascending position. ascending position order. Okay, so basically we will press stat then number 1, which is edit, and look for number in the 7th position. In the 7th position. So it's 1, 2, 3, 4, 5, 6, 7. 24 is the number in the 7th position. In the 7th position. Answer is 31st percentile is 24. That is 31% of the numbers are below it. Of the numbers in the data set are below it. Is below it. Okay, so that's your answer. Okay, 35 percentile is 24. Okay, so please do not quit. Please stick with me till the end. I'll give you some important tip at the end. So let's take a look at the last part. Part C is what is the percentile position for 38 in this data set? So part C. Position of 38 in the data set. Count the number of numbers. Count the number of numbers below 38. Below 38 in the data set in L1. In L1, arranged in ascending order. Arranged in ascending order. Ascending order. Okay. So let's go and take a look at how many numbers are below 38. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, no, 12. No, 13, 14, 15. So actually 14 numbers are below it. So 14 numbers are below 38 in the data set. In the data set. Okay. So percentile position of 38 in the data set. 38 in the data set is 14 plus 0.5 divided by total number, which is 22, times 100. So this is the percentile position. 14 comes from numbers below 38. So let me erase that and write it clearly. Numbers below 38 22 is total sample size. So this is equal to 14.5 times 100 divided by 22. Let's see how much it is. So in your calculator, you're going to calculate 14.5 multiplied by 100 divided by 22 is 65.9, which should be rounded to 66. That's your answer. So what is your answer? Your answer number 638 is 66th percentile. What does it mean? It means that is 66% of the numbers are below 38. 66% of the numbers are below 38. So that's your answer to part C. So as I said, I will give you some important tips. So let's start from the top. So first thing what we did, we entered the data in L1 and then look for the 5-number summary, which is min x, Q1, Q2, Q3, and max x. Then we calculated the interquartile range. That is, what is the range of the middle 50% of the numbers, which is Q3 minus Q1. Then we multiplied the IQR by 1.5. Now from Q1, we subtracted 1.5 IQR to establish the lower outlier boundary. Any numbers below it would have been an outlier. There's none in this data set. Similarly to Q3, we added 1.5 IQR to establish the outer or upper outlier boundary. Again, we found out there is no number greater than the upper outlier boundary in the data set. Hence, this data set has no outlier at all. Okay. Next, we had to find a 31st percentile. So it is the position of that number is 31 divided by 100 times 22, which works out to about 7. So we arrange the numbers in the ascending order. And when we look from the lowest number, we go up to the 7th number, and that number worked out to be 24, okay? Which means that 31% of the numbers are below 24 and 69% above it. Next, we are asked to find out the position of a particular number, percentile position of a particular number. That number was 38. We went to the list L1, which has already been arranged in the ascending order from lowest to highest. We found out how many numbers are below 38, which was 14. To that, we added 0.5 and divided by total sample size of 22. And we got 65.9, which is rounded to 66. What does it mean? It means 66% of the numbers are below 38. That is, the percentile position of 38 in this data set is 66. Vice versa, that means 33 per 60. So 38 is the 66th percentile, 66% below it, and remaining 100 minus 66 is 33 on top of 38. So 66th percentile is the position of 38. So I stop here today. If you have any question or comment, write me a note. If you like this video, please give me a hearty thumbs up. I really appreciate that. That motivates me to do more problems just for you. Okay. If you like this video, share with your friends. You and your friends, please subscribe to my channel, Math Science Topia, by hitting the red subscribe button. And please do not forget to watch me tomorrow when I'll be back with another interesting problem, interesting solution. Thanks for watching. Take care and keep coming back to my channel, Math Science Topia. Please subscribe and let YouTube know that you will like to be notified every time I upload a new video. Thanks. Take care. Have a nice day.